Well, why wouldn't everybody want something if it was free? Some people just don't want it. So think of something that you would have no interest of even if it was for free. So that would be Garrett and his Pizza Pops. Doesn't care if there's free, he's not going to eat them. So there's always going to be a number of people that want it, but there's going to be a bunch of people that don't. That's why we can have a specific value. Ooh, allergies, good point if we're dealing with food. And we're going to make a note, this is always a positive value. Why? Yeah, you can't have a negative demand. So the B here, which this becomes confusing because it's not the B that's here, it's actually M. And we know in general math terms that's the slope. What it means in terms of economics is called the price sensitivity of the consumer. The price sensitivity of the consumer. The larger the slope is, the more the effect a price change will have. The smaller the slope is, the less a price change will have effect. So we're going to talk about more of that in a second. This is called the price sensitivity of the consumer. So if this is a large number, what price sensitivity means, an increase in price will have a large effect on QD. We're not going to write down, but the opposite is true. If it's a small number, an increase in price will have a small effect on QD. So it's called the price sensitivity because it's as the price changes, how do we as consumers react? Do we have a big reaction and we go out and buy a lot, or are we kind of like, so-so about it? That's what the value will tell you. And we know that B is always going to be negative. Why? And that is called the law of demand, right? So law of demand dictates this will always be a negative number. Effect. Number? Number? Large number. Large hashtag, economics. There's the theory behind it. Let's do an actual practical example. So here is a standard kind of demand question in economics. The demand function for toy cars is given by QD equals 60 minus 5P. We're going to draw the demand curve. We're going to discuss the impact of 60 and negative 5, so what do they mean in context for the situation. And then we're going to talk in general, what do the changes affect? So as A changes, what does that mean for the toy cars as B changes? Okay, draw the demand curve. How do we graph a line? We just practice this. Okay, so before we started with the y-intercept, except this isn't the y-intercept now, what is it? It's the x-intercept, and this isn't rise over run anymore, what is it? If we flip that, it becomes, but in terms of the math, it's run over rise. So you need to think in terms of this backwards. If your brain is like, whoa, let's start the first one with a table of values, because that's going to be the easy way to do it until we start thinking backwards. So I'm going to put price and I'm going to put QD. And let's start with the price is 0. So we know that's going to be the x-intercept when price is 0. When the toy cars are free, how many people are going to want? Well, this is just substitution like it is in math. So 60 minus 5 times 0 is 60. Let's pick a price of $1. Okay, so that would be 60 minus 5 times 1. So, close. 55.
Oh, sorry, I didn't see it. It's not.
And if it was a $2 car? And if it was a $3 car? What are these jumping by? Why does that make sense? Because that's the slope. Okay, let's jump some. Let's do 10. Offer of 10. Does everybody see where that came from? Okay, and let's do 20. Okay, so can we have a negative value? So that means 20 is too big. You cannot have a price of 20. Okay, that's over the maximum price. What goes along the bottom? Always, always, always. Oh, thank you. What goes along the bottom? Always, always, always. We don't have X and Y. They're out. QD, quantity is always along the bottom. What's along the y-axis? Always, 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 always. Price. Price, do you want to jump by 1s, by 2s, by 5s, by 10s, by 20s, by 100s? What would you like to jump by? 5s, and do you want to space them 1 every 2 line, or do you want to go every line? Okay, so if this is 0, that would be 5, 10, 15, 20. Okay, so look at this huge graph that we have, and our numbers are only to here. So was that a good choice? We did go by 5s. Okay, so we want to try to use the whole graph because you have a little demand line here, it gets really hard to read. Okay, so that was not a good choice. It's a choice, it's not a great choice. I heard 2s. So then we're going by 1s but only writing every second one? Can someone tell me if we have enough space before we start writing? Okay. And if your brain would rather write every number, great, do it. So because the only value we have up to is 10, now we're going to be using this much of the graph. So was this the best choice? Okay. So now we're going to theory number 3. I know, but we have an X there. And sometimes this happens. That's why I always do my axes in pencil, because sometimes you don't see it till you start writing it out. So you want to go up for 1s. Do you want to jump by 2s? Yeah. Okay. Left-sided brain people, this upsets them. The graph is all messy now. So for some brains, it's helpful sometimes maybe not to just put the X, but to cross it out, because then maybe your brain won't see it when you're deciding on the axes. So if that works for your brain, do it. If not, no problem. What about along the bottom? Okay, so we have to go to 60. We got 5, so 5 is good choice. Okay, so let's count it out before we draw it out. So this would be 5, 10, 15, 20, 25, 30. Ooh, okay, that's going to run out. Okay. You want to jump by 6s? Okay, so 6 here. Because these are divisible by 5, I'm just hesitant to do 6s. You can do 6s if it works, but some people that's hard when it's divisible by 5. Okay, so 3 spaces, 2 spaces. Isn't that what we just did? Okay, so 10, 20, 30, 40, 50, 60. Oh, what is close enough?
That's using like all the space there.
What, you got all this that's left over?
But you can't go up by 3s because then it's going to be like the dot's going to be in a weird place. It's not going to be on a line.
Are you left-brained?
No.
That was very left-brained, not wanting to divide 3 in half. Very left-brained. I'll go with good enough for this one.
Great question. Are you left-brained?
I always ask that.
Do you really?
Yeah.
I never asked that question.
We do learning styles at the beginning of the semester, so they know if they're left brain, right brain, visual, tactile, or auditory.
See, the questions I ask at the beginning of the term is, Will you bring me chocolate for Mark?
Always, always a good question. Okay, so these are economics,
Yes.
not math.
I know.
Do you think they're more right-brained or left-brained?
It depends.
Well, okay, in general, what do you think?
Well, in general, it depends. It's like, well, because, I mean, it's, you have to have a certain amount of, real-world analytical stuff.